Hello. We're starting 4.1, but in general, we're going to do chapter 4 called Dealing with Uncertainty and Introduction to Probability. So, Friday, January 15th. We have a number of goals. We're going to define fair game, experiment, simulation, trial, outcome, event, event space, sample space, simple event, compound event, independent event. We're going to define on the back side of the handout probability, experimental probability, and theoretical probability. Example 1. Identify the specific part of the example that matches each term and definition. So we've got a term and a definition here. And then we've got some examples that we're going to apply the definition to. So fair game is a term that means that each action is equally likely. So this is a fair game since getting a tail or getting a head are equally likely. So fair game because you have an equal chance to get a tail or head. Example B, you withdraw one card and hope to get a queen. Is this a fair game? Yes. Fair game. Why? Well, another reason, other than the fact that these are equally likely, right? So fair game because each card is the same size. Same size, right? There's no distinguishing between the tail that your coin flips to or the head, so that makes it a fair game. So fairness is about getting an outcome that is equally likely to another outcome, but it's also the idea that one outcome doesn't look or appear or feel or seem more likely than the other, okay? So experiment. Use the real objects to determine the outcome. So this is an experiment because we use the actual coin. Okay. B, this is an experiment because we use a deck of cards. Okay. Simulation. Substitute the real objects with other outcomes, or other items, I should say, to determine the outcome. So the actual object that we're using is a coin. So a simulation, replace coin with paper. Okay. One would have to be a tail piece of paper and one would have to be a coin. We could do a simulation. Here, replace the cards with paper as well. Now, the catch is that we would need two pieces of paper, one for each outcome, right? So when you flip a coin, you could get a tail or a head. So you'd need two pieces of paper for your simulation in A. And here, you'd need 52 pieces of paper of equal size and weight to represent your possible cards, okay? So your trial is any repeated action. So what are you doing here? You are flipping a coin. So the trial is the coin flip. Okay. And your trial here is you are withdrawing a card. Okay, it's the action. So the outcome is the result of the action. So when we have a coin flip, our outcome, there can be two, right? It could be a tail or a head. Here, your outcome, the result of withdrawing a card, my goodness, you could have multiple outcomes. You could have 52, right? So you could have hearts, which are ace, 2, 3, all the way up to jack, queen, king. And then you could have spades, of an ace, 2, 3, all the way up to jack, queen, king, diamonds, of an ace, a 2, a 3, all the way up to a jack, a queen, a king, and you could have clubs. Clubs. I don't play cards, so I had to think for a minute. So clubs, you could have an ace of clubs, a 2, a 3, all the way up to a jack, a queen, and a king. Okay? The event is the outcome that you hope for. Okay? So in this case, you flip a coin and you hope to get a tail. Right? So your event is a tail. You hope for a tail. Okay, so your event here, okay, and you hope to get a queen. Okay, it's your desired outcome. Okay, so your desired outcome. So your event here is a queen. Now, what you can specify is the fact that you could have a queen from each of the 4 suits. So you could have a queen of hearts, diamonds, spades, or clubs. Right? So you don't care what suit the queen is from, but as long as it's a queen. So the event space is a specific list of the desired outcomes. So really, the event space, we get fancy and we just go like this. We do the forehead, nose, chin bracket, and we just say tail, right? So your event space here is the queen of hearts, okay, the queen of diamonds, the queen of spades, and the queen of clubs. Okay, just use short form there. The sample space is all of the possible outcomes in an experiment or simulation. So hopefully you say, I'm seeing a pattern here. Okay, so event and event space are really talking about the same kind of thing. It's in the notation that we start writing, fancy brackets, okay? And a sample space is connected to the outcomes, right? So the sample space is all of the possible outcomes in an experiment or simulation. So our sample space are all of the possible outcomes. So that's a tail, head. So see how the sample space is connected to this one here, right? And then our sample space for B is us listing them, right? So I would have a hearts, ace of hearts. I'll go like this. Ace of hearts, a two of hearts, a three of hearts, all the way up to a jack of hearts, a queen of hearts, and a king of hearts. And then keep going. So you're just recopying here. So you have an ace of spades, a two of spades, a three of spades, all the way up to a jack of spades, a queen of spades, a king of spades. And then you've got diamonds. So you've got an ace of diamonds, you've got a two of diamonds, you've got a three of diamonds, all the way up to a jack of diamonds, a queen of diamonds, and a king of diamonds. And then we need the clubs. So we need an ace of clubs, we need a two of clubs, a three of clubs, all the way up to a jack of clubs, a queen of clubs, and a king of clubs. Okay, so is there much difference between a sample space and an outcome? No. They're connected. Okay, so just know that those are really talking about the same thing. Okay, a simple event is there's only one way to obtain your desired outcome, also called a single event. So there's only one desired event. Okay? Or outcome. And that is equal to a tail. Okay? So therefore, it's a simple event. Okay? However, here in example B, you can be satisfied with 4 possible cards. Okay? So your desired there are 4 outcomes. Okay? That fit our criteria for getting a heart. Okay, so if there's one, okay, it's a simple event, i.e. one event. If there's not just one, there's more than one, okay, so therefore not a simple event. I'll see if I can give you more room here in this chart. Okay, compound event. There is more than one way to obtain your desired outcome. This is not compound, right? So it's not compound because it is a simple event. In other words, it's a simple event or it's a compound event, right? It's one or the other. So is there more than one way to obtain your desired outcome? This is compound in B, okay? Because there are 4 ways, okay, to obtain a heart, right? Independent events. Each outcome is not affected by the next outcome. So this is for repeated trials. Okay? So we don't really have a situation where we talk about independent events if we're just flipping the coin once. But if we flipped the coin more than once, okay, each outcome would be independent from the other. Outcomes. In other words, if my coin flip gave a tail first, my second coin flip could be a tail or a head. It wouldn't matter what my outcome prior to that would be. In other words, the coin is not going to think about its previous outcome and control the next outcome. Okay, here, again, independent events talk about the fact that you have more than one trial, right? So if we withdrew more than one card, okay, and didn't replace the withdrawn card, okay, then we wouldn't have independent events. But if we replaced each card we withdrew, we'd have independent events. The reason, I'll have to talk quickly here, is if you don't replace your card, you have one less card to pick from, okay? And that influences what happens. In other words, if you withdraw a jack of spades, then and not replace it, then you don't have an opportunity to get that card in your next withdraw. Okay, I'll touch base with you in a second.